Craftsman Days are here at Lowe's with big savings on the tools you need. Save $100 on the Craftsman V20 6-Tool Power Tool Combo Kit, now at $199. No matter what the project is, Craftsman's high-quality, high-performance products empower you to build on. Stop by your nearest Lowe's store and check out the full line of Craftsman tools today. Valid through 6/18 while supplies last. Selection varies by location.
This is SpaceTime, Series 28, Episode 64, for broadcast on the 28th of May, 2025. Coming up on SpaceTime, a new study shows that Jupiter was once twice as big as it is now, how gamma-ray flashes are unleashed by lightning, and spaceflight history made as two spacecraft orbiting the Earth fly in millimeter-perfect formation. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
A new study has found that the solar system's largest planet, Jupiter, was once twice as big as it is now and had a far stronger magnetic field. Jupiter is the fifth planet from the Sun, and the gas giant has more than 2.5 times the combined mass of all the other bodies in the solar system, excluding the Sun. Its diameter of 140,000 kilometres is some 11 times larger than that of Earth, and it's a full 1/10 the size of the Sun's diameter. Jupiter is huge. That's why it's often referred to as the king of planets. It circles the Sun at an average distance some 5.2 times further out than the Earth, taking 11.86 Earth years to complete each orbit. The new findings, reported in the journal Nature Astronomy, suggest that around 3.8 million years after the solar system's formation, 4.6 billion years ago, at a time when the first solids condensed out of the Sun's protoplanetary disk, Jupiter was significantly larger and had an even more powerful magnetic field. One of the study's authors, Konstantin Batygin, says the ultimate goal of the research has been to pin down the early phase of planetary formation. Batygin and colleagues reached their findings by studying Jupiter's tiny moons, Amalthea and Thebe. They orbit even closer to Jupiter than Io, the smallest and nearest of the planet's 4 large Galilean moons. Now, because Amalthea and Thebe have slightly tilted orbits, the authors were able to analyse these small orbital discrepancies in order to calculate Jupiter's original size, finding it to be about twice that of its current radius, with a predicted volume that was equivalent to over 2,000 times that of Earth. They also calculated that the planet's magnetic field was some 50 times stronger than what it is today. This new analysis is establishing a clear snapshot of Jupiter at the moment its surrounding solar nebula evaporated. And that's a pivotal transition point where the building materials of planet formation disappear and the primordial architecture of our solar system was finally locked in. The results add crucial details to existing planet formation theories, suggesting that Jupiter, as well as other gas giants around other stars, were all formed through a process of core accretion in which rocky and icy cores are first established and then rapidly gather surrounding gas. This is SpaceTime. Still to come, a new study describes how gamma-ray flashes in Earth's atmosphere are unleashed by lightning, and spaceflight history has been made in Earth orbit, with two spacecraft successfully flying in millimeter-perfect formation for several hours for the first time. All that and more still to come on SpaceTime. Scientists have detected intense flashes of high-energy gamma rays associated with the collision of two bolts of lightning. Lightning is a phenomenon that's fascinated humanity since time immemorial, providing a stark example of the power and unpredictability of the natural world. Although the study of lightning can be challenging, scientists have, in recent years, made great strides in developing their understanding of this extreme spectacle. Now, a report in the journal Science Advances has described for the first time observations of an intense burst of radiation known as terrestrial gamma-ray flash synchronized with a lightning discharge. The study's lead author, Yuki Wada from the University of Osaka, says the ability to study extreme processes such as terrestrial gamma-ray flashes originating from lightning allows scientists better understand the high-energy processes occurring in Earth's atmosphere. It's been hypothesized that terrestrial gamma-ray flashes arise from lightning discharges as a result of the acceleration of electrons to very high speeds. However, the transient nature of this phenomenon, which only lasts for microseconds, has always made it difficult to study the hypothesis. So Weider and colleagues developed a multi-sensor setup designed specifically to detect optical, radio frequency, and high-energy radiation events. They were able to observe two discharge paths of lightning, one descending from the thundercloud to the ground-based transmission tower, and one ascending up in the opposite direction. Weider and colleagues found that terrestrial gamma-ray flashes occurred just before the two discharge paths met, creating a highly concentrated electric field that accelerated electrons in the air to near the speed of light. The first terrestrial gamma-ray flash photon was observed 31 microseconds before the collision of the discharge paths, and the full burst lasted for 20 microseconds after they met to form the lightning strike. The study contributes crucial data to the long-standing mystery of how lightning generates enough energy to produce gamma rays, a phenomenon normally associated with outer space events like supernovae or black holes. The study also supports emerging theories about lightning leader dynamics and the potential role of thermal runaway or relativistic feedback in these extreme bursts. This is SpaceTime. Still to come, spaceflight history made in Earth orbit, with two spacecraft successfully flying in millimetre-perfect formation for several hours for the first time. And later in the science report, researchers develop a new type of contact lens, one that will help you see in the dark. All that and more still to come on SpaceTime. Today's episode of SpaceTime is brought to you by Insta360, the game changer in 360-degree camera technology. Now, if you've ever wondered how some creators manage to capture those jaw-dropping third-person shots, the ones that look like they've been taken by a drone following you, well, that's probably Insta360 magic. Their latest model, the X5, isn't just another action cam. It's a fully blown immersive video powerhouse, putting a production studio in the palm of your hand. The X5 captures 8K 360-degree video, meaning you're recording literally everything around you at once, forward, backwards and sideways. And here's the kicker, you don't even have to aim. Just press record and enjoy the moment, and then reframe your shot after the fact with the Insta360 app's AI-powered tools. Want to follow your movement, lock onto a subject, or create stunning 360-degree pans? Well, now that's just a few taps away. And for those epic how on earth do you film that shots, the invisible selfie stick's your secret weapon. It vanishes from the footage, giving you that cinematic floating camera look, perfect for POVs, adventure reels, or even space-themed explorations right here on Earth. Plus, with a larger sensor and a dedicated night mode, your low-life footage doesn't just survive, it thrives. Think clear skies, dazzling cityscapes, or even a starlit time-lapse. This is hands down the best 360-degree image quality Insta360 has delivered yet. So, if you're a creator, explorer, or just someone who loves telling stories in a bold new creative way, the X5 is ready for launch. To bag a free 114cm invisible selfie stick worth $24.99 US with your Insta360 X5 standard package purchase, head to storeinsta360.com and use the promo code SPACETIME. But be quick, it's available for the first 30 standard package purchases only. And for more information, be sure to check out the links in our show notes. Head to storeinsta360.com and use the promo code SPACETIME. And now, it's back to our show. Spaceflight history has been made in Earth orbit, with two spacecraft successfully flying in millimetre-perfect formation for several hours for the first time, and without any control from the ground. The European Space Agency's Probe 3 mission achieved the precision alignment which is needed in order to carry out its mission to study the Sun's outer atmosphere, the corona. You see, the two Probe 3 spacecraft, which include a chronograph orbiter and an occulter orbiter, need to fly exactly 150 metres apart in perfect formation in order to simulate a single giant spacecraft. Now, earlier this year, the first step of the mission was successfully completed. Using a set of positioning instruments, flight operations managers were able to align the two spacecraft in formation and then monitor them as they maintain their relative position autonomously. Now, following more fine-tuning and testing, the team have achieved the desired level of precision they need, making Probe 3 the world's first ever precision formation flying mission. ESA Probe 3 systems engineer Raphael Rougeau says the task was carried out at an orbital altitude of 50,000 kilometres. Here, Earth's gravitational pull is small enough so that very little propellant's needed to maintain flight formation. But then the formation's broken and needs to be acquired again over the next orbit in a repeating cycle. Now, the ultimate goal is for the two spacecraft to align with the Sun so that the 1.4-metre disk carried on the Occulta spacecraft casts a 5-centimetre shadow onto the optical instrument aboard the chronograph spacecraft, thereby allowing it to study the faint solar corona, the Sun's outer atmosphere. The spacecraft are able to measure and control their relative position using a visually based system, which includes a wide-angle camera on the Occulta tracking a set of flashing LED lights on the chronograph spacecraft. Once the satellites get close enough to each other, a narrow-angle camera locks onto the same set of lights, enabling more accurate positioning. Then, a fine-degree lateral and longitudinal sensor laser is used to achieve the millimetre accuracy needed for the mission. That laser is fired from the Occulta spacecraft and reflected by the chronograph's retroreflector back to the Occulta where it's detected. Finally, a shadow position sensor measures light intensity around the chronograph aperture to ensure the spacecraft stays in the shadow cast by the Occulta spacecraft. This report from ESA TV.
Prober, from the Latin for let's try, is ESA's family of experimental small satellites. Over the last 2 decades, Prober missions have pushed forward spaceflight technology while gathering valuable science data. The next in the series, Prober 3, is the most ambitious yet. 2 satellites fly together as one with millimetre-level control of their positions within a precise formation. In the process, one will eclipse or block the Sun for the other, to reveal our star's faint surrounding coronal atmosphere for scientific observation. Prober 3 requires a unique orbit. The Occulta spacecraft, with its 1.4-metre diameter occulting disk, will observe the Sun in eclipse. The satellite's orbit is highly elliptical, taking them to a maximum of 60,000 kilometres from Earth. Gravitational, magnetic and atmospheric perturbations are much lower this far out. This will make possible the precise positioning needed for formation flying and observing the Sun's corona. At this stage, it is important that the Prober 3 satellites perform a series of maneuvers to position themselves in relatively safe orbits with respect to each other. Achieving this nullifies any risk of the pair either drifting away from each other or colliding. The separation between spacecraft will be as short as 25 metres and as long as 250 metres, with a nominal separation of around 150 metres. The pair determine their relative positions using a suite of metrologies, including radio links, satellite navigation, and the visual-based system with optical tracking of blinking lights. Once sufficient accuracy has been achieved, the final step to deploy the most precise measuring system of all, the laser metrology system, known as the fine lateral and longitudinal sensor. With this laser link, the total 3-dimensional formation can attain millimetre-level control. At this point, the Occulta, lined up with the Sun, will cast a perfect shadow for sustained observation of the Sun's otherwise invisible corona. Once the Occulta's shadow is maintained in just the right spot on the face of the other satellite, it will be safe for the coronagraph to open its protective door and start scientific observations of the Sun's corona. Solar scientists travel the world to glimpse brief solar eclipses, but Prober 3 will create eclipses on demand.
This is SpaceTime. And time now to take another brief look at some of the other stories making news in science this week with a science report. Scientists have developed a new type of contact lens, one that will help you see in the dark. A report in the journal Cell claims the lenses work by converting infrared light, otherwise imperceptible to the human eye, into visible light. And unlike night vision goggles, these lenses don't need an external power source. The technology behind the lenses rely on nanoparticles that absorb infrared, which the authors bonded with non-toxic polymers used in standard contact lenses. When tested on people, participants could detect the location of flashing infrared lights, which they wouldn't be able to see without the contacts. Now, additionally, the authors say they could alter the nanoparticles to convert different wavelengths of light into different colours, thereby allowing colourblind people to see colour. Now, currently, the lenses can only detect infrared light projected from an LED light source, but researchers are now working on a version that could detect lower levels of infrared light out in the wild. It turns out the humpback whale's epic migrations to tropical waters from the Great Southern Ocean are not as essential as previously thought for giving birth. A report in the journal Frontiers in Marine Science documented newborn calves around Australia and New Zealand, with the southernmost found at Port Arthur in Tasmania. That's 1,500 kilometres further south than what it was previously thought humpback whales could calve. And the highest latitude births recorded by humpback whales were recorded even a little bit further north, off Kaikoura, New Zealand. The authors say it's very likely that this pattern of births along the so-called humpback highways always existed, but it was obscured when the population crashed due to whaling. A Microsoft artificial intelligence called Aurora has been shown to outperform existing Earth system forecasts, predicting extreme events including weather, air quality, ocean currents, sea ice, and hurricanes. Existing methods need to analyse decades worth of data and they require huge amounts of computing power. A report in the journal Nature claims all that data was fed into Aurora, and the AI successfully outperformed 7 forecasting centres in predicting the route of cyclones 5 days in advance with 100% accuracy and 92% accuracy for 10-day forecasts. Even better, training Aurora only took 2 months, whereas existing methods can take years. Of course, it was only possible to train the AI so quickly because all that data used to train the AI had already been collected by existing Earth forecasting centres. Google have held their major artificial intelligence showcase I/O 2025. With the details, we're joined by technology editor Alex Zaharov-Reutt from TechAdvice.life.
Yes, well, they've had their major Google I/O 2025 event, and this is where they announced a lot of new things about AI. So one of the first changes that people in the US will see on the Google homepage, instead of seeing the I'm feeling lucky button, it will be AI search. And this is where you're effectively talking to Gemini and getting a full AI agent similar to what you get with ChatGPT or by going to gemini.google.com. And it will expand what you get with the AI overviews and be a full-on assistant right there on the most famous homepage in the world. You'll also be able to use that with Google Chrome. It will be able to navigate multiple tabs for you, be able to tell you what's on a web page. You can question that and talk to it. They were showing a demo where your assistant could ring up a store and get information about items in stock and come back to you and actually take actions for you. Now, these are still coming, later this year. I mean, the Google homepage update is available now for those in the US. The Gemini Live app itself that gives you the ability to not just speak to the chatbot like you could with ChatGPT or Grok, but also now you can see. So we've spoken about this before, but this previously was made exclusive to the S25 range and Google Pixel phones. Then it was expanded to more Android phones, and now it's available to all effectively modern Androids going back several years, and also iOS. Now, I have tested it on my phone with iOS, and I don't have the camera icon there yet. It's probably something that is waiting for an update to come, but you'll be able to hold your phone up to anything and ask questions about it, identify plants, animals, looking at instructions on how to put together some IKEA furniture, whatever it might be. This is like talking to a robot, except you're holding the phone in your hand. But there's plenty more. I mean, Google Beam is an update for Project Starlight, which was the ability to talk to people in what appeared to be like a 3D way, even though you were sitting in front of a 2D television screen. Now, HP is going to launch these big TV screens / monitors with 6 cameras that will take images from various viewpoints around you and simulate a 3D image. So you will feel as though you are actually talking to that person in a way that is more engaging and more real than just the way we do with Zoom and Google Meet and FaceTime and Skype. Another example of Google's prowess was with the Google Meet Zoom equivalent, where somebody was speaking in Spanish, somebody was speaking in English. And a couple of seconds after you start speaking in your language, it's being converted into Spanish if you're speaking English. And it's being done in your tone of voice. In the demo, it was very quick and lifelike. It's effectively pretty much in real time. updates to Imagine 4, the image editor, VO3, the video editor, were now delivering much more realistic images. And with the video, it could pair that with audio that would match the physics of what was on screen. So they had a gentleman in a boat, the waves were crashing, or just moving, and you could hear them. It was very realistic. And they've actually now got a thing called Flow, which takes all of their tools together and can make movies for you just by describing each scene. And you can extend a scene and export the clips. Really quite incredible. Also, an Android XR headset that's extended reality being made with Samsung and Qualcomm. Looks very much like the Apple Vision Pro, except, of course, it's running Android. And then also these glasses looking like a pair of black-rimmed Ray-Bans, for example. And there was a camera, and you could talk to Gemini, and you could see images that popped up and were translucent, so you could see through them, but they were in your field of view. You could pick up a map, for example, and see the directions. If you look down, you would actually see a little map displayed there, and you could speak and see subtitles of what somebody else was saying and have that translated into another language. Lyria 2 was audio. It was part of the suite that creates the videos, and that was able to make this orchestral, beautiful sounding, rich music. Pretty amazing stuff. It's effectively all available now. How long it will take until it comes to Australia is yet to be seen. The Flow video creation tool is part of Google Gemini Ultra. Now, this is in US dollars, $249.99 a month. First 3 months are at half price. There was also a pro version for about $20, and that's clearly it's free as well. But if you want more rate limits, as it were, and the ability to do more with the latest tools as they come out, I mean, this is next level stuff.
That's Alex Zaharov-Reutt from TechAdvice.life. And that's the show for now. SpaceTime is available every Monday, Wednesday, and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favorite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.